we have a statement that cannot be proved.
Excellent, excellent. So what he said is maybe because it stays incomplete, it is not powerful enough to drive at least some true statement. Maybe we should add more axioms to it so that it becomes complete now. What Godel says is this: if you add more axioms, then that's another system, and the same proof works for that system. That it isn't. Now you add more axioms. Now you are. So Godel did not talk about a particular system. It said whatever system you come up with, if you think it is rich enough, complete, and consistent, it's wrong. And that is called Godel incompleteness theorem. Theorem इसलिए कि उसने इसका proof दिया था. इसका proof उसने उसी system के अंदर रह के दिया था जो उस वक्त rich system था. Number 3.
What is the sort of difference between complete and addition of? I don't understand.
Sorry?
What is the difference between complete, system is complete, and system is rich enough?
Rich enough means it can state things like इन्होंने अभी एक बात की थी कि atoms की क्या बात की थी?
The atom is the most fundamental particle.
Atom is the most fundamental particle in the world. That's it. That's a statement. If this system is rich enough, it should translate that system to its symbols and language as a proposition. That is what we mean expressive and rich enough. Complete means if this statement is true, it should be derived through the axioms.
So by completeness, it means the sort of the set of axioms and rules of inference.
And they are all combinations, all derivations. For every true statement, there is a derivation. If this is the case, then the system is complete. It can derive every true statement. Rich enough means it can state several things. Well, ideally, it should state everything. और मैं proof इसका show करूँगा. That's Godel incompleteness theorem. Godel incompleteness theorem 1.
Can you give an example of system which is not rich enough?
Yes. So for example, a system with these alphabets, and the system with all the strings made up from these, and that strings are for example finite length strings. And then the rules के how these bit का bit के साथ AND करें तो कैसे लेते हैं, bit का bit के साथ OR करें तो what does that mean, P implies Q, what that means, and so on. If you, for example, limit that every proposition should have length, the bit length, so every sentence in this language, you are defining a language, this should be not more than 100, that's it, you're just restricting it. Then it cannot express a lot of things. Just for example. Make sense? Godel first incompleteness theorem, that we will prove today. We will see the proof. We'll see the proof. He says, if you try, अब ये मैं थोड़ी सी जो statements बोलने लगा हूँ, ये मैं इसकी एक interpretation करने लगा हूँ. If you try to understand each and everything, which means you're going to express each and everything in your system, then further, if you want to stay out of contradictions, then there will be some things that will be true, but not in the reach of logic. There will be things, there will be statements that will be true, not drivable. Not drivable means what? They are beyond the reach of logic. That was the first incompleteness theorem. And let me tell you, I have gone through this history in recent weeks. After that, huge debate started that never ends till today. Philosophical implications of Godel theorem, practical implications of Godel theorem, and so on and so forth. Sayyidi, Godel's second incompleteness theorem that will not prove today, that we just stated. I will not prove today that. Let me just state this. Second incompleteness. First incompleteness theorem is if the system is expressive and then it is consistent and complete is false. One of them or both of them has to go out. Second theorem is rather more confusing. A system cannot test its consistency. I will not prove that today. Let me just give you a flavor of what he did. If you have a system, you claim that it is consistent, then to prove that it is consistent, you cannot prove that system within the system. He doesn't say it is not provable. What he said is, staying in that system, you cannot prove the consistency of that system. With that, he said, you need another system, which is called a meta system, out of that, and that will talk about this system. That can decide about the consistency of this system. But then the question is, who will be deciding the consistency of the meta system? Well, there is a meta system.
This one will complete data.
Yes. You cannot build a system staying in which you can prove its consistency. That's his second. Yes? Third theorem. Godel completeness theorem. If your system is not rich enough, then you can enjoy both problems. Which means, if you're going to understand each and everything, you are making your system very expressive, then you break down. Stay limited, talk about it, happy. Make sense? Yes, no?
Yes.
That's the claim. We are going to prove first claim. If the system is rich enough, then it is consistent and complete. This statement is false. Yes? You need a break? Or should we continue? Your call. How many of you think there should be a break now? How long?
No, please.